The fifth question that we have is an interesting question again. We have a crystal AB which has a rock salt structure. Rock salt structure means NaCl structure. It has molecular weight of 6.023 into Y AMU. We need to find out the minimum distance between cation and anion is given to be Y raised to 1 by 3 nanometers, and observed density is given. We need to find out the theoretical density and the type of defect. So finding this out, let us first find out the theoretical density as in the density by our calculations. So for finding out the density, we must first analyze the structure. We know that since it has an NaCl structure, in NaCl what happens is that Cl minus ions are present on the face centers and the corners of a face centered cubic lattice. Therefore, the number of chlorine ions in a particular lattice is equal to 4. That is 1 from the contribution by 8 vertices. 1 by 8 into 8 is equal to 1, and another 3 by the 6 atoms at the face centers, that is 6 into half, that is equal to 3. Therefore, total is equal to 4. Therefore, there are 4 chlorine ions per unit cell. Similarly, since the formula is NaCl, therefore there will be 4 Na plus ions in this unit cell. The Na plus ions are present in the octahedral void. Similar will be the case for AB. Therefore, we have a total of 4 molecules of AB per atom. Therefore, we can find out the density as per unit cell. Therefore, in one unit cell there are 4 molecules of AB. Therefore, the total mass of AB in one unit cell will be equal to 4 into the molecular weight 6.023. This will be in grams. Therefore, we multiply it by 10 raised to minus 3 upon Na. This is the mass of 4 molecules of AB. This is 6.023 into 10 raised to 23 and divided by the volume, that is equal to, now we need to find out the length of the unit cell. Now we can clearly see that it is given that the distance, minimum distance between a cation and an ion is Y raised to 1 by 3 nanometers. As we had previously seen that Na plus ions are located in the octahedral voids. Therefore, Cl minus ions, Na plus ions and Cl minus ions again are located in this fashion along the edge. This is the center, and therefore this is the edge of the unit cell, and its length is A. This is clearly equal to twice the minimum separation between the two ions, that is equal to 2 into Y raised to 1 by 3 nanometers. This can be written over here, 2Y raised to 1 by 3 into 10 raised to minus 9 whole cube. On solving this, the answer comes out to be equal to 5 kg per meter cube. Therefore, the answer for the theoretical density comes out to be equal to 5 kg per meter cube. We now need to find out, or rather interpret, the type of defect depending on the comparison between theoretical density and observed density. Now, as we see here that the observed density is greater than the theoretical density, that means that the type of defect is non-stoichiometric, which has occurred due to either metal excess or non-metal excess. This is non-stoichiometric defect. Solid in such cases seems as substitutional or interstitial solid. So final answer is that the theoretical density comes out to be equal to 5 kg per meter cube and the type of defect is non-stoichiometric.